the review test, this is it. Oh, this still says 7.1210. I wonder why it says that. This should be 1.1. We are on 7.11. We're going to build a sinusoidal model from data. Baby, that sounds like fun. All right. All the directions. Got to enter the data. Got to make sure we're in radian mode. We're going to go to stats. We're going to go into sinusoidal, all this stuff. So in order to save time, which is sort of a pain, I've put this stuff already in my calculator. But we do need to create a scatter plot of this information. So the months are going to be 1 through 12. And then we got to put those temperatures in. So I'm going to quickly scatter plot this stuff. It's only 12 points. Shouldn't take me too long. So let's see. Let me get to my red pen. And at 1, we are at 29.7. 1 is 29.7. Probably right about there. At 2, we're 33.4. Somewhere around there. At 3, we're at 39. At 4, we were 48. At 5, we are at 57. At 6, we are at 67. At 8, no, at 7, we are at 74. At 8, we are at 71. And at 9, we are at 62. At 10, we are at 51. At 11, we were at 39. Sorry, I'm trying to find 39. 39's right here. So we went from 51 to 39. Is that 51? No, it's 55. There's 51. This is not good. This point doesn't exist. At 12, we were at 31. All right, so, and as you can expect, so there's my scatter plot. That almost looks like an upside down absolute value, but as you can suspect, it's going to probably do something like this, you know, because its temperatures are going to go up, it's going to go down, and it's going to go up, and it's going to go down, and so on and so forth. Now, don't connect the dots. That's not part of a scatter plot. But what we want to do is define the sinusoidal regression equation for this data in this table. We're round the answers to the nearest hundredths place. So I got this stuff in my calculator already, trying to save a little bit of time. So I go over my calculator, month and temperature. There they are. I'm going to go menu, statistics, stat calculations, and I got to go find sinusoidal. There it is, sinusoidal. Now, I used month and temp for this one, so I got to be careful. I use month and I use temp. And I click OK. So there's my sinusoidal regression equation. It's A times sine BX plus C plus D. So I need to have an A, B, and C, and D. So let's get those. First, let's get the equation written down. The equation is going to be Y equals A sine BX plus C plus D. I know we call this end one C, but this is what the calculator does. So we need A equals, B equals, C equals, and D equals. And in a matter to save time, let's round everything to the hundreds right now. So 2.15. I don't have my answers here. Oh, there, she's got them right there. 21.15. B is 0.55. C is negative 2.35. and D is 51.20. That's our midline in that case. All right, so if I wanted to write my equation then, round to the nearest hundredths, it would be 21.15 times the sine of 0.55x plus, minus 2.35 plus 51.20. Wow. Okay, there it is. There's my equation, kids. That is my sinusoidal regression equation that represents this data. Is that all I had to ask? Scatter plot, represent, find the equation. Round, there it is. All right, so let's do another one. Let's see if I should. I'm going to pause and I'll be right back. All right, so I got two more. We're going to draw this one. This is the monthly temperatures for Washington, D.C. Maybe they're a little higher. I don't know. We're going to find the sinusoidal regression equation. It models this data, and we're going to round this one rounded to the nearest tenth. So the first thing we're going to do is draw a scatter plot in. So January was 34.6. February was 37.5. I hate when it does that. March was 47.2. April was 56.5. May was 66.4. June was 75.6. Oh, this is June. This is May. This is garbage. And July was 80. A little higher temperature down there. And then 78.5. And then September was 71.3. And October was 59.7. November was 49.8. And December was 39.4. And again, it looks, there it is again. It's going to go up and down, up and down, up and down. That's the temperatures. That's what temperatures do around here. Unless, of course, you live on the equator. And it's still going to go up and down, but not quite as dramatically. So we're going to go over here. I typed these in already as well. So we're going to go monthly. We're going to go menu, stats, stat calculations. This is still month. And this one I use temp to. And we're going to have I used linear regression. Son of a gun. See how dumb that is? That's dumb. I just randomly picked, and then what? Copy those numbers down because that's what I did? No. Menu, stat calculations. I still got to find sinusoidal regression. Pick the right one. Month. Temp 2. Click OK. Yes, overwrite it. Okay. Whew. That would have been dumb to do that. There's my sinusoidal regression equation. Again. So y equals a times sine of bx plus c plus d. This time it said round to the tenths place. All right, we'll round to the tenths place. A is 22.6. B is 0.5. C is negative 2.0. And D is 57.2. All right, there's my equation. Y equals 22.6. That's my amplitude. 0.5x, that's my frequency, plus minus. Now, the C we don't know about. That's actually what's called a phase shift. Shifts left to right, minus 2.0, plus 57.2. There's my midline. So midline would kind of be like the average year-long temperature. So in Washington, my midline average year-long temperature is about 57.2. This one was 51. Now that would make sense. This is Colorado, which is a little bit colder than Washington, D.C. You know, if I was talking about Hawaii, maybe my midline then might go up to 70. If I was talking about Florida, it might be 70. I don't know. If I was talking about Alaska, it might go down to like 35, maybe the average overall. So again, this is my midline, right? So it's my kind of my average temperature of the whole year. If I drew in my midline, 57 degrees. There's my amplitude. I'm going to go up by 22 and down by 22. Approximately, kids, approximately. All right, last one. All right, so on this one, let's see. The amount of light a location on Earth receives from the sun changes each day depending upon the time of year and latitude of that location. The amount of daily sunshine Kansas City experiences is shown in the table below, where the calendar day is X and the number of hours sunlight is Y. So that would make sense that we do about 350 days. That's almost the whole year. So we're going to do a scatter plot of all this. It's going to take me a couple minutes because there's a lot of them. Luckily, there's not 350 of them. At day one, now they should probably tell us what day one actually represents. But since there's very little light at day one, I'm going to guess day one might be January 1st. So day one, we're at 9 hours of sunlight. At day 16, we are at a little more than 9 hours. At day 32, we're still at about 9 hours. But we're getting close to 10. Really close. Gosh, I hate that. Really close to 10. And at 47, we are at a little over 10. So this scale to me is useless. So I want to adjust that scale. We got to get up to at least, it looks like 15 hours, about as much as we got, and as little as 9 hours. So I'm going to redo this. This scale doesn't make any sense. I'm going to have an awful time of this. So I'm going to make this 9, 10, 11, 12, 13, 14, and 15, and 16. So this scale was useless. So that's the idea. Do you see how those points were all going to be all jammed in there? That doesn't make sense for a scale. Why would anybody do that? Let's do this. Let's do a little break here. Let's say the bottom is 9. So at 1, I'm at 9.21. So right here, 9.2. Then I'm at 9.4 at 16. Then I'm at 9.9 at 32. And then I'm at 10.48 at 47. I'm 10.48, so 10.5 approximately. And then at 60, I'm at 11. And at 75, I'm at 11.7. And at 91, I'm at 12.4. So now this is a much better scale. 106, I'm at 1307. At 121, I'm at 13.7. At 136, I'm at 14.2. At 152, I'm at 14.6. That was at 152. Yeah, that's about right. 152. And at 167, I'm at 14.9. 167, I'm at 14.8. And 182, I'm also at 14.8. And at 197, which is right about here, I'm at 14.6. And at 213, I'm at 14.1. I hate that. And at 228, I'm at 13.6. And at 244, I'm at 12 I'm at basically 13. At 244, I'm basically at 13. At 259, I'm at 12.25. At 274, I'm at 11.6. 274, I'm at 11.6. These are all approximate. At 289, I'm at 10.9. At 289, I'm at 10.9. At 305, I'm at 10.2. At 320, I'm at 9.75. At 335, I am at 9.37. And at 350, I am at 9.1. So if I had to guess what my midline was for this, I would guess my midline, or average number of hours, is somewhere going to be around between 11 and 13 hours. Right? That's my average year-long sunlight in Kansas City, it appears. So what we're going to do is, I've got this data I've already put in, thank goodness. And so we're going to do sinusoidal regression on this. Sinusoidal regression. So I'm going to go to calculator, go to 3, and I'm going to do menu. And again, make sure you do sinusoidal regression, not linear regression. Stat calculations. And I got to scroll down. I don't remember what it was. It was C. In this case, I used day and sunlight, or sun, and click OK. So here's my regression. So y equals a times sine of bx plus c plus d. I think the answers are below, but it doesn't matter. A equals, B equals, C equals, D equals. What are we going to round it to? Nearest tenth. So 2.8. Now that's just dumb. Let's go hundredth. So 2.80. B is 0.02. C is negative 1.38. And D is 11.97. These are the same numbers I got down here, I hope. Yeah. So rounding this to the hundredths place, to the tens place, would be dumb, because you'd end up with 0, which means you'd have no x, which means you'd have no frequency. So that doesn't make any sense. So my final equation is y equals 2.80 times the sine of 0.02x minus 1.38 plus 11.97. Now, didn't I say my average temperature was going to be somewhere, my midline was going to be somewhere around 12? I was right. So now one of the things I can do is go over and graph this sucker. So let's go on. Let's graph this thing. So we're going to graph it from 0. Now the highest amount of sunlight was 15. So let's go. Yeah, no, we didn't go over 15. Let's go 15. We did it for 350 days. And the lowest I want to go here is, let's go 5. Okay? So escape. So now I got to graph it. So tab, let's graph this function. 2.8, so 2.8, the sine, parenthesis of 0.02x, 0.02x minus 1.38 plus 11 point, was it 97? 97. Enter. There it is. Now that's just about exactly what we graphed, isn't it? It's about exactly what we graphed. Looks good. Looks good. Now what if I said I want to know what the temperature will be on the 280th day? On the 280th day. Well, if that's my equation right there, that's my equation. I can do a couple things. I can just do, let's see, menu. Let's see, can I calculate? Used to be able to. Menu. Analyze graph, calculate, no, table. Well, whatever. The easiest way to do it is just come over here and just say take 280, control var x, hit enter, and then just type that in. 2.8 times the sine of 0.02x minus 1.38 plus 11.97. Now, what I should end up with is a 280. I should end up with something between 11.6 and 10.9, approximately. It's a little off. It's a little off. And that could be just an estimation error based on what's going on, but it's not overly off. You know, I asked for 280. So that should be between 11.6. It's quite a bit off. It's more off than I thought it would be. But it may not be a great regression model. At any rate, there it is. A little bit of sinusoidal regression. That actually ends Unit 7. Next is statistics. Yes. All right, kids. Hit the subscribe button. Hit the like button. Hope you like this stuff. And keep working hard. We only got 3 units left. Bye.